All right, as I said, let me go ahead and move this. We have class shape, and here we define the individual fields or the data, and in this main method we have calc triangle. So we call the outside method outside of the main method. Here is the outside method. So right now we are still in the main class, but yet we have another method inside the main class. So we are isolating. We're actually isolating the. Sorry about this. We are isolating the behavior from the data, kind of, but the data is displayed, or the data is delineated or defined in this main method, and we're calling the outside method from outside of the main method. But even though we're in the same class, this main method is a class. It almost is an entity in of itself. So can you tell me whether or not this will go? So I've already compiled this, and I'm just going to quit it. And let me make it so that I move this here, and it's not agreeing with me, and that's because I need to do this. Okay, there we go. Vim shape. Now let's run it. So we're going to do Java shape. Enter. Okay, the area of this triangle is 10.0. Okay, and my apologies. Let's do vim shape.java. Okay, there it is. Let's quit. And we're going to compile. I thought I had compiled it before. I guess I didn't. Okay, that is the issue. Java, that when I try to compile it, okay, I get these errors. We cannot find the symbol. It doesn't know base, it doesn't know height, and it doesn't know shape. Now let's take a look at this program again. We have calc triangle, and we have public static void calc triangle. Why do we even need the static keyword? The reason why we need the static keyword is because, let me shrink this. It is because the static keyword allows us to access this outside method without instantiating it. This static keyword allows access without instantiation. And because we are outside the main method, we actually have to access this method, even though it's just a method, utilizing the static keyword. Otherwise, we would have to instantiate it with the new keyword, and we don't want to do that. So looking at this, it doesn't know, it cannot access height, base, and shape because it doesn't know. We need to redefine it here. So let's do that. If it, let me let me type I for insert. Okay, so we have double base, double height, and string shape. And because we are adding these parameters, we need to do the same here. So base, height, shape. So these parameters have to match these parameters when we actually call calc triangle. And when we call calc triangle, these become arguments because we have already defined base. Where did we define base? We defined it here in the main method. So now this should work unless I have misspellings. That would be the benefit, if you will, of doing things in IntelliJ. So we're going to compile it, and wouldn't you know, I still have an error right here, and it says cannot find symbol shape. All right, let's take a look. At least we're down to one error, and shape is triangle, string shape, and wouldn't you know, it's because I accidentally made an error with capitalization. So string shape. There we go. That should have removed the error. We're going to compile. Remember, compiling is where the errors are, I guess. We have now removed that error, so let's go ahead and run it. Java shape, and as it says, the area of this triangle is 10.0. So we were able to run it successfully. Okay, now let's do another improvement. So that's a refactoring one. We're able to successfully isolate our calculation in its own method. But look at how ugly that is. That is ugly. Double base, double height. I mean, look at that. I mean, that is just horrendous. Double base, double height, string shape. I mean, this parameter takes up so much real estate. Wouldn't you want to get rid of the parameter? So one way we could get rid of the parameter is by maybe making another class. So we make this so that we remove this, we take this calculation and we just move it all into whole nother class. Okay, so now, and let's just get rid of this. So now we have calculation and reporting in another class, and the class can we can just create another class dedicated to calc triangle. And now all the main method it does is run the outside class. So this becomes its own class, and this becomes its own class. We have two entities. And the reason why this works is because, listen, Python, you can do everything really easily in one entity. You can define the data, and then you can define the behavior. And within the behavior, you can calculate, you can graph, for example, create graphs like with matplotlib. That's in Python. And you can do anything. So the data and the behavior are defined in one, and some of the behaviors include calculation and graphing and things like that. But what happens is if the graphing itself needs to be changed or adjusted, then you have to go back into good code. And the problem with the problem with this is to start out, you're probably using more code. In essence, you're creating, another entity. So this is one entity, the one we did in Python, for example. The one we do in Java, here's entity 1 and here's entity 2. But here's the thing. If by chance we needed to change something of how we calculate the triangle area, we just go into this class and ignore this class. Okay, when we go into here, we got to compile. We have to compile the whole entire thing. Here, we need to recompile just the calc class. And that leads me to, it's not necessarily improvement, it's a refactoring. Refactoring opportunity, I'll just say opportunity to expand it to its own class. And we can see here that the difference is now we have, and I kind of did it already in IntelliJ, shape. Now we just have a class dedicated to running it, and we have a class dedicated to presenting to you the data and presenting to you the calculation. Okay, and that's what we do here. Let me bring back up the PowerPoint. So we now have class shape2 on its own. Here is one class. And then here is another class, my shape. Now, how does that look like if you were to I don't want to say graph because I just used that graph. If we were to create a UML type drawing, okay, a UML type drawing now, for this one, we go from everything in that first slide, we go to everything in this one class. Now we have two classes, and we're isolating what they do. This first class, we'll call it the main class, and then here we call it the everything dedicated to the shape. So we'll just say my S. So the main class does nothing more than run the class. All it does is, as you can see, this is the class right here. All it does is it instantiates the myShape class, and it creates a variable my triangle, and then with my triangle, it can, with the dotted operator, we can see that it calls calc triangle right here, and calc triangle, and of course that's a method, and the method's carrying no, and here's the thing, it's carrying no parameters. See that? No parameters. Unlike this, when we want to calculate the calc triangles, here's all the parameters in the world. Here, there's no parameters. And the reason why there's no parameters is because here, the data and the behavior are in the same class, or they are in the same entity. And how is this possible? Through the concept of encapsulation. Because encapsulation binds the data and behavior into one single entity. And the improvement is twofold. First of all, it is just naturally better to have things organized. In other words, there's a natural separation between the main class, which contains the main method, and all the main method does is it is instantiating or igniting or creating the ignition switch for all the other classes that you choose to run, because you can have different classes right here, and it looks like we're choosing to run the myShape class, and that's all it takes. And then once we have created my triangle as the name of this object, now through the dotted decimal, the dotted decimal, and we now have access to all of this. Now let's take a look. And what I would like to do is I would like to X this out, or comment that out, and just keep this in my triangle equals new shape. And now what is this screaming? Why is this even here? Let's see. Expected. I don't know why this is screaming at me. Anyways, my triangle equals new shape, new myShape. So let's do my triangle dot. Now we can see that it has access to the following: shape, calc triangle, base, and height. And that represents all four members. The myShape has the following members: base, height, shape. Now these are the data members, or the instance variables. Okay? And this is the only method member, or the behavior. So again, now what would happen if we kind of not overrode, but we're defining shape equals triangle? Okay? What will it show? Now it's saying shape equals triangle. Here, let's just call it my triangle. Okay, let's see. So we go from triangle to my triangle. Let's see who wins. And wouldn't you know, the reason why the error is there is I forgot the curly brace, and I need to add another curly brace, because the first curly brace is the end of the main method, and the next curly brace is the end of the main class, which is shape2, because that's the name of this whole entire program. Okay, so let's run it. and it says new triangle. Okay, but we don't see if it's going to also accept my triangle. So now we have to access calc triangle. So let's do that. So my triangle dot calc triangle. Let's click on this. Let's see who wins. New triangle, and the area of my the area of this my triangle is 10.0. So it did accept. So in other words, my triangle, because I defined it in the main class, has essentially been writes over the default value of triangle. So what this means is that these are default values. These are simply default values. So let's do my triangle. Let's do dot base equals 40. Save it. And we can see that it took 40.0 over and above 5.0. Okay? So in other words, if we don't even really need, we can just do this and this. And what we can do is say base is this, and we can say my triangle dot height equals, we can say 50. Well, let's do 450 for the heck of it. And we can see now that the area has gone up to 9,000 because we can define it in the main method, and that will essentially overwrite the local values right here. Okay, but we can put in our backup values 1.0 just for the heck of it. But when we write it in the main method will always override these local values. Okay, let me run this. It still says the area of the triangle is still 9,000. Okay, so this is encapsulation, because here we have my shape, which is a separate class, and we have bound, if you will, the data and the behavior into one single entity. Thus, that is encapsulation.